Alright, today we're looking at a LeetCode easy problem, 13 Roman to integer. Roman numerals are represented by 7 different values: I, V, X, L, C, D, and M. Here are the symbols of the value. For example, uh, uh, 2 is written as I in Roman numerals. Just 2 ones added together. 12 is written as X, I, which is simply X plus II, and 27 is written as XXVII, which is XX and V plus II. Roman numerals are usually written largest to smallest from left to right. However, Roman numerals for 4 is not I. Instead, the Roman numeral is written as IV, which often because the one is before the 5 was subtracted. Uh, uh, it makes it 4. The same principle applies to the number 9, which is 1x, and there are 6 instances where the subtraction is used. So I is placed between V and X, X before L and C before uh, D and M. So here's an example of it. So let's just define our total is equal to 0. We're just going to return total. Then for this bit, we need a dictionary. Basically, we can define a dictionary using a new dictionary, and we'll make it char, a character, and an integer, and we'll just add the values to it. So basically, we're gonna have I, and that's equal to 1. So basically, this whole thing, we just need to add it to our dictionary. So that's I, then V, then X, then L, then C, then D, and then M. Just get rid of this one. So this is 1000. D is 500. C is 100. L is 50 and 10, and then we have 5. So we basically start off with this dictionary. The next step is basically we have the string S, and we just have to loop through it. Which is a for int I is equal to 0, I less than s dot length, and I plus plus. And basically what we need to do is do it a dictionary and the value of s and I. So if you look at the first example, we'll see we're gonna get I. So if you look at the example, this will handle this case. I think it will handle. So if you get an L, we get a 50, we get a V, we get a 5, and I. That should be able to handle it. But we have this bit of logic over here which says, okay, but if we have an I, if you want to get a 4 or a 9 or a 40 or a 90 or a 400 or 900, then we have to do something different, which is because the one before the 5 we subtracted. So so this edge case we need to handle. So for this one, basically we need to have an if condition, and our normal logic can basically go in the else condition. So the logic here basically states that if the the value is less than the next value, so as I if this is smaller than uh, uh, this one, I plus 1, then what we have to do is we have to subtract this one. Uh, so uh, basically we subtract that one. So if we get an I and we know the next one is a V which is greater than that, then we subtract the I, and the next one will be uh, next time we'll get a V, we add that to it. That should handle that case. Uh, the only thing, since we're doing an I plus 1, there's a chance we could, well, this we're definitely going to go outside the bounds. So we have to add another check here. If I plus 1 is less than s dot length, and so if I plus 1 is less, and then so basically if we're at the end of it or close to the end, we basically just want to add it. And if it's a, if it's IV, then we subtract it, and then go on from there. Uh, so yeah, that should handle all the cases. Let's just run this to see if there are any errors. Uh, yeah, that should be a length. Total does not exist. And okay, yeah, that should be an A. Let's see if there are any more errors. Okay, we solved these thing, the easy cases. That should be. Let's try the edge cases. Let's just submit this. And we're able to solve this.